wait a second to see if Twitch catches up. Okay, I seem to be live. Welcome back, everyone. Welcome back to one more stream of the Compiler project. So, last time on Tuesday, we made some progress on the analysis phase, which was the main thing we've been working on for the last few weeks. I did rewrite some of a core thing that has been a pain for the last few weeks, which is I have, in my dependencies when I'm compiling a module, a compiled version of the constants and functions and things that are imported from other modules. But in my current module, I don't, because, I'm currently compiling that module. How do I handle the fact that functions within my module might reference types in other modules or in the local module, when the types that represent those two things are different? That has been kind of an annoying problem, and we solved this in a way that I think is satisfying last time, which means we could resume working on doing the proper analysis of. We've done most types at this point. There's a lot of checks we haven't done yet, but we have done some of the checks, and we did more work on analyzing constants and their expressions. There's a lot of things that are missing there, but that's probably what we can make a lot of progress on this evening. And my goal, if we make progress there, I might not do everything. There's a few things we might just decide to not do for the moment. The second part will be trying to start making progress on analyzing functions and doing type checking and name resolution on functions. I don't think we're going to be able to do everything this evening, because I'm sure there are also things I haven't planned for yet that we're going to discover live. But yeah, that's the plan for this evening. Let's get started. I go back here. Perfect. So here we were last time. This gigantic function was, we're analyzing a constant declaration, which means we have found in the file that we're compiling a constant with its type and the corresponding expression, and we have to handle all possible types of expressions while trying to analyze a constant. Constants are a special case. There's a lot of things which are not allowed. For instance, calling a function in a constant value is not allowed, because the value of a constant must be possible to determine at compile time. As a result, we did a lot of work on handling multiplication, division, and so on last time. What we have not done is comparison. We haven't done range operations, partly, and I think those we might not do this evening unless I figure out how I want to represent some special built-in types like vector, which are going to be very special given the language we're targeting. And we did make some progress on some of the Boolean operators. What's left, I think, really is to handle, again, comparison and some of those special cases here. And then we can move on to functions. Here I had some very extremely rough code for a cast expression, which is this value as this type. At this point, the type of a constant will always be known, because there cannot be type parameters for a constant, which means we should be able to fully know what the type of the cast we are getting and the type of the expression that we have, what they are. And we can therefore check at this point whether the cast is valid or not. And we can also do things like boundary checks for enums. So we find the cast expression, we resolve the underlying expression, we resolve the type, and at this point we know what the type that we're casting the expression is, but we also know what the inferred type of the expression is. Now we just have to decide whether that cast is valid. And the thing is, it might not just be I can't just say, oh, it only works on built-in types, like int can cast to character, character can cast to int to boolean, boolean to int. Those are obvious and we can handle them. But I need to go beyond that, because another type of cast which will be allowed will be will be from an enum value to an int, or from an int to an enum value. And in the case of a constant evaluation, we can actually check like that the values are valid because we know what the constants are at compile time. I'm thinking also that we might want to extend the cast operator to also handle cast of vectors of types that are themselves castable. Therefore, a vector of int could be cast to a vector of character. But since, again, we don't have yet a notion of vector, that's something that we will need to have strings. For now, I think I'm going to skip that. So, what that means is I'm probably going to need to check. I also haven't decided. There's a thing that's a big to-do that we haven't done. At the moment, in the scope of our program, and that's something we're going to have to do this evening to check that the code we're going to write right now works, we don't have the name of enum values in scope. We create at the beginning of the analysis phase a scope of things that are available at the top level of the module based on the imports from other modules and the declarations that are local. We create this map of like, what are the things in this current scope? What does this name map to? And we do not have such a mapping for enum values, for enum constructors. So we're going to need to add that. I am not entirely sure how I want to do this. If I want to like create fake constants basically at the top level and pretend that there's like fake constants there, or do I want to just basically make the values point to the declaration of the enum, and then when I'm trying to resolve something, determine whether it's pointing to the name of the enum or to one of the values within. I have not decided yet. We'll pick one of the two when we do that later this evening. I'm probably going to pick the latter because inserting false declarations might make error reporting a bit more difficult down the line. So, here we are, cast. I'm going to need, therefore, to resolve. I have this resolve type, which is just a path to like name and arguments of a given type. Like this could be vector with argument int, or it could just be int with no arguments. And I'm going to need to know what the corresponding declaration is, if any. At the moment, there are cases where getting a declaration might return nothing. For instance, type arguments of something that has a generic argument will not have a corresponding declaration, and built-ins do not have a corresponding declaration, but that's something we're going to need to fix. So I will probably be able to rely on. I think, yes, resolve name is what I want, which is given the path, a resolved path info, which what a type name is, give us whatever this callback returns, which in our case will be just a declaration. I guess I could introduce a function for this, which is just give me the declaration. The problem is I can't do that. Because again, there's two different kinds of declarations, the passed and the resolved. So I can't write a function that returns an arbitrary one of them. That's the reason why we have this complicated resolve callback thing. I guess in the context of the cast, the only thing that matters is whether it's an enum. Because I don't think I want to support cast of arbitrary structs, at least not at this point. So I think what I want is to introduce a equivalent to all of those functions. Duplicate this one, which is going to be a resolve enum. That gives me a maybe. Actually, enum info does not depend on the phase. When we pass or when we resolve an enum, there is nothing that changes because an enum is just a list of constants, basically. So here, actually, this is slightly wrong because I already have resolved path info. So I can't do it like this. Okay. So this doesn't work because I don't have the proper type to give as an argument. So I guess I guess I will want just to make a special case of resolve name and give it a callback. Okay, yeah, let's do this. I'm gonna introduce a slightly different version of this function, like I was doing. It's gonna be resolve enum from name to distinguish them from the other resolve functions that are resolved from the original identifier. This one relies on a name that is resolved. Actually, I could just probably just give the name. There we go. And this returns a maybe enum info. And this is going to be calling our resolve path function? No, I don't think it is. It's going to be calling not resolve path, but resolve name, which takes the callback, but the resolved version. So this is resolve name with some go callback and the path info, which is here, well, which is the name, which we might not need to name. We don't, because resolve name gives it as an argument to the callback, which has this type. So it's going to be given back. We don't need to give it as an argument explicitly there. Okay. So this is going to be our callback, which returns a maybe enum info. And from this, what we'll do is, so this takes as an argument the name and a maybe declaration, if any, either resolved or not resolved. But in either case, it's going to be the same type here because enum info does not depend on the phase of the AST. So what I want to redo here is, I think we might just want to use the monadic property of, because we just want this to short circuit. We're not going to be making any call. Yes, we just want to know. Maybe actually this should not, yeah, I'm going to name this function differently. All of the resolve functions so far are trying to like assert that the thing is what the thing is. So resolve struct will throw an error if we're trying to resolve something and it happens to not be a struct. Therefore, since our behavior here is completely different, I think this should be named differently. Naming this properly is the hardest problem in all of computer science. How do I want to name this? Try resolve enum from name to make it very clear that this one is okay with failure. Not the best name, but so here, I guess I could rewrite this simply as I can rewrite this in a lot of different ugly ways. I'm trying to think of what the least ugly is, because it is. That is a valid thing. I'm using this operator as the implementation of the function, and I'm giving this first argument a lambda case, which creates an anonymous function that does a case on its argument. Because we're going to take a maybe value and return a new maybe value if depending on what was inside, which is just a bind in the maybe monad. So this is technically a valid way of doing this, although maybe not the most elegant. I think it's fine. And so here I can. However, no, I think I'm not going to do this just because I need to unpack the fact that the declaration comes with location information that I don't care about. Which means, yeah, let's do this properly. So this being a do block in the maybe monad, this will short circuit if there was nothing in the declaration. Otherwise, we do get the declaration here. And now I can do this case here. Oops, give me 1 second to check if this is urgent. It is important, but not urgent. And so here, most of those cases are not important because I am not trying to throw an error saying we were expecting an enum, we got something else. Here, I can just say that any other case, regardless of what it is just nothing. I wonder, I think maybe implement monad fail, which means that if I do something like in a do block foo decomposed from just for pure for and close the expression, that works obviously, except he doesn't know what this is. I'm just gonna do it differently. Okay. And if I do this where I do... Can I do... I'm gonna need something else. Let's say I have a data color which is red, green, blue. If I have a do block in the maybe monad and I do this red from just green, which will fail, and then pure 4, which happens to be an int, I'm expecting this to return nothing and not a panic. Okay, perfect. That means here I could go 1 step further and do, instead of doing a case, I'm just going to do this decomposition, rely on the monad fail instance. Or I could even go 1 step further and do... Yeah, yep, I can just do that. I don't think I can do it, however, with a bind into a lambda. I don't think that's gonna work. For instance, if I do just green bind into a function from red to just for int, yes, that's not gonna work. So I think this might be the simplest solution. Okay. So this will give me the enum info if and only if the thing I was pointing at was an enum. Okay. So let's go back to what we were doing. There's something I just thought of which is slightly wrong in the code here. I'm gonna need to resolve this is the target type. And I'm also need to resolve... Well, actually, no, that's fine. The type will be resolved as part of the expression. However, I will need to check target enum will be try resolve enum from name of the resolved target type, and source enum will be try resolve enum from name of path name of the resolved, not path name, sorry. Whatever the typed expression. The expression type of the resolved expression. Okay, and now we can try to handle all of the cases. I'm gonna just introduce an alias here for readability, which is gonna be this. There we go. Resolved source type, resolved target type. Do I want to do this a case, or do I want to do this? I might not be able to do assertions. Yeah, I might want to do it differently. Let's do just the case on the enums. If we get if we're trying to cast, excuse me, if we're trying to cast a value that is, if we're trying to cast a value that is from an enum to another, that's, I think that's valid because enums are always going to be represented as simply integer values. So as long as the bounds allow it, I see no reason to refuse it. Then we have to handle the case where the source type is an enum, but the target is not. In which case, I think the only valid conversions will be Boolean, character, and int. We have to handle the case where only the second one is, which likewise will only be int, character, and Boolean. And finally, we'll have to handle the last case, which is neither of them is, which is the common case of converting between types. And here, as a result, we'll only need to handle, again, I think, just integer, Boolean, and character. Let's see what this last case looks like, and we'll see then how we can try to generalize to the others and try to avoid repeating code. The thing is, I don't want to do a case here. It would be nice to be able to do a case expression like this. I guess I could try. I guess I could try with patterns actually. Because the problem is I cannot, in a case, say a value that happens to be equal to that other one. Unless I use patterns. This might be a lot better. I don't remember how those work exactly, but this is a perfect occasion as any to go look at how they work. Because if I remember correctly, those are exactly the solution to what I want to do here. Abstracting from the representation to expose matchers that behave in a constructor-like manner with respect to pattern matching. That's what we want. The example will even include int, which is literally the thing we're trying to do. Perfect. So it's just okay. What's the syntax? There's bidirectional patterns, and let me just be sure that I know what I'm doing. 3 kinds even. Okay. We can use it in the pattern context to deconstruct values and in an expression context to construct values. We want that. Unidirectional isn't what I want. Okay. Okay. The explicitly bidirectional pattern is when I want okay. Which I think isn't what I want. I think what we want is the very simple case. Okay, perfect. So let's go to our built-ins. And unless I'm mistaken, then I can rewrite this as being a pattern. And I can just give it a name. Does it have to be? It probably needs to be named in the way that matches a constructor, so therefore with a capital letter. So this would be pattern. What do we want to name the pattern for an int? Because int is something that already exists in Haskell, so I can't reintroduce int there. Int type, I suppose. The syntax is just pattern int type with the arguments, and then okay. Will it need to be in the same file that introduces the path info, or is this fine? I think it's fine. Okay, so if this is correct, which so this becomes int type, r type, boolean type, then there are a few places in this code that I can rewrite to actually match on the type properly. For instance, here I could say, I could include resolved source type, resolved target type. In the case where they're both enums, those values do not matter, regardless of what they are. We will try. We know that they are enums, therefore their names don't matter. However, in the case where we don't have an enum for the target, then here we can use the case match to try. We probably don't. I probably don't want to include that in the case. It probably makes a lot more sense to make it a separate case here. And do here, well, let's do a case on the resolved target type of. I'll have to report that spammer. And here I should be able to say if it's an int type, do something. If it's a character type, do something. If it's a Boolean type, do something. Likewise, in the case of only the source being, the source not being an enum, which would be resolved source type then. And in this remaining case, that I would technically not have to name, because if we are in this case, it means none of the other things have matched, which means we are in the nothing nothing case. I can do, therefore, a... Do I have to handle all combinations? Or can I just handle saying, can I do this without basically using a case? Is my point. I think it's still valuable to have the case and have the pattern. Can I do it without? And I think the code is going to be the same in all those cases because the underlying representation of all of those things, it's not always going to be an int literal. Now, I think for those, I have to handle those three differently. No, I have no choice. I think I have to handle this. That being said, I might not do it this way, in the sense that the actual type doesn't matter, because given that we're in the case of a constant, where everything has to be resolved, if the underlying expression did resolve properly, it has been reduced to being a literal expression. So if it is, I don't have to test the type. I can test the expression directly. Not here. In this case, where I'm trying to do a targeting thing, I have to do this. And I have to therefore handle the case where we get any other type, and I have to report fatal. This could not be performed. There's an error here. In a case where we're going to an enum, but I don't, I have a literal value, I could do the case directly on the resolved expression, which I think is value of the resolved expression. And here, instead of doing those int type and everything, I do have an int literal underneath, or I have a character literal, or I have a boolean literal. I could do it with the type, but it would be redundant information. Unless we've done something wrong, like as in unless there's an internal compiler error, testing this is the same thing as testing, do I have a type int, a type character, or a type boolean in the context of a constant. In the context of a function, this will not work. I will have to test the actual type. Because in the context of a function, something that is an int might not be an int literal. It might not have been folded back to an int literal. It might be just a function call. Okay. I'm going to remove a bunch of white space because it's not aligned line by line anyway. There we go. And in this case, what do I want to do? Can I avoid the 9 different cases? I think I can. Because all of Boolean integer character can be represented as an int and then converted back, which means I could do something like this. Which, I guess I will have to handle vectors separately when we have vectors. But we don't have those yet. So I think I can do something like this. So we do the same thing. If we have we have an int, a character, or a boolean, then we return this int, an int representation of the character, or an int representation of a boolean, so 0 or 1. Anything else is an error we cannot cast from that type. Reward fatal undefined, but cannot cast from type X, whatever X is. That's not something we support. And then the target will be case of the target type of if we are trying to return an int, then our result is going to be a typed expression of type int type with the value which is that's int value unchanged. If we're trying to return a character, then it is going to be a character type. And converting this int value into a character. And if it's a boolean, then we return a type expression of type boolean. Oh, this is slightly incorrect. This is an int literal with the int value. This is a character literal with this, and this is a boolean literal with this. There we go. Okay, and now we should be able to handle all 9 conversions that don't involve enums without having to handle without having to do the 9 cases manually. We will need to handle other cases like vectors or things that can be converted, and string will probably just like be an alias to vector of character ahead of this case, which will be the default case of we are not in a special case of vector. But we are not there yet, and that should be good enough. I am going to introduce error wrong cast. This is, again, the diagnostic type will have to change. An error will not just be any enum value like this. It will be a structure that contains the location of the error, some additional information about the scope where we are. Like we are currently on line 35 within the for loop of the state of this statement of this function, something like this. And will have then an associated enum, which is this enum. But for now, I just do the enum. I haven't done the rest. Wrong cast will have to resolve typed, which is from and to. And that means I can start. So here, I'm just going to introduce it as a alias here. If we have to report that something is wrong, this will be an error wrong cast from source resolved sourced type to resolved target type. There we go. I could go even further and introduce this as being report fatal of this, which is an expression of type, like of type value within the monad, but isn't evaluated at this point, which means now I can say here wrong cast diagnosis, or just cast error, I guess, or maybe report cast error. There we go. Report cast error. report cast error. Same thing here. And same thing here. Now, I probably will want to introduce a helper to do the same thing in all three of those cases, which is that I'm doing here, which is I want to convert to an enum. And not this case, I suppose. Which means I might want to maybe move this case as the second one. I'm trying to convert to an enum, which means basically extracting the int value of the left-hand side and then checking that it's within bounds of the target enum, which is going to be the same code in both cases. I might just duplicate it twice, it's not the end of the world, especially if it's that close. I might make some effort in deduplication when we do functions and we end up having the same code. So, there's a bit of duplication, which is never elegant. So we have the same thing here. So we get the int value, which in the case of an enum is simply gonna be the index. Let's see. Why are you so slow? There we go. Because we have an enum info here, which simply contains a list of identifiers, which means we need to look. Do we actually? I think we don't. I think what I'm going to do is whenever we get a value of type enum something, I will replace it by a corresponding int literal instead. Despite the type of the expression being enum, it will be represented within the EST as an int literal instead, which I think makes everything easier. So that means that this case here will be instead this, and here in this case, it's not a cast error. This is an internal compiler error because given that we have checked that the type is enum, there should not be any possibility for the actual evaluated expression to be anything but an int literal. That is not something that is able to happen. So in this case, we can throw an internal compiler error. The user has done nothing wrong. The problem comes from within our code. Okay, so here we do the same thing. We retrieve the int value in both cases. I can remove this case here. And I guess I can do the same here in the case of the enum. Okay. So we get the int value from the enum or from the left-hand side if it's not an enum for all the cases we can handle. And then to convert to an enum, so here this is going to be the same thing. This is both cases we're converting to not an enum, so this is basically this is the same thing as this. This feels like a lot of duplication. I don't really like this. I might introduce helper functions just to avoid that. And finally, when we're converting to an enum, what do? We just have to check that the int value is within the bounds. And how do we do that? I guess a simple when is enough. So we have the int value. When int value is greater or equal to the length of the target enum, which is an enum info, which is the enum value, length of the enum values of target enum, which I suppose we could cache because doing length of the list every time we do this comparison is kind of ugly. But again, we'll do for now. When that's the case, then we want to report a fatal error, which is going to be a different one from cannot cast, which is going to be an error. We're going to want to, in the case of a cast, of a dynamic cast during a function expression, we'll want to introduce an actual, like, live dynamic error, like printing an error message and panicking, basically. But here, this is going to be a compile error. And I guess error enum out of bounds with an int. Or do I want to? What is in the enum info? It has a name. Okay. Yeah, I think I want the full enum info. And int. Okay, back to here. When int value less than 0 or int value greater or equal to the length of the enum values of the target enum, report fatal. And this is going to be an error enum out of bounds of the target enum. The enum and the value, which is the int value. If this error happens, we short circuit, therefore the rest of the code doesn't execute, which means here we can return a very simple typed expression, the type of which will always be, I guess in all of those, I don't have to actually type out the type. I could just use the resolved target type, which is always going to be the same. I'm just going to do that here, resolve target type, which is going to be the enum in question, and the value will be an int literal of the int value. And I'm going to duplicate this for this case here. Okay. I think at this point we can try to see if it compiles. We can't test enums yet because we don't have enums in scope yet. I guess we can try to see if this compiles. It won't, but we can fix this. Not in scope, data constructor in type. Do I need? I know I have some patterns here in my prelude. They're not enabled by default. Okay. I don't know if looking at this, I can give it type. That's interesting. I don't think I need to do that. I think this is gonna be enough. Aha. No. Okay. This is ambiguous. What did I change? Oh, I did not commit last time, I think. I did not commit last time. Okay, that's a mistake. It doesn't matter. This is... Yes, this is a name. This has to be resolved. So, okay, I can introduce 3 more of those. There we go. And for each of them, I can say this is a path info resolved. Now it should be fine. Will I need to also include pattern synonyms in this? I think so. Is there any downside to activating pattern synonyms project-wide? Ah, this is not the problem. Interesting. Oh. This wasn't the problem. The problem is not with my int type. This is something else. Okay. This is... I am trying to resolve... Ah, yes, I think they're not called int literal, car literal, they're called int literal expression. Okay, so all of those needs to be prefixed by expression. Okay. I've missed one here. Couldn't match a with location declaration with... Yes, here... If this is... Yeah, I suppose I have to do a fmap located. Okay. Yes, this returns not just a maybe value, but a maybe value within a monad. This do block is the maybe value, but it needs to be put in the monad. So this is a pure do. Okay. And now we have a few errors coming from... I am trying to create a thing with the int path that no longer exists, which therefore means I have to use this int type. I'm almost tempted to introduce some aliases for int expression now that I know how those pattern synonyms work, because that will be a lot easier. I don't think there's a lot of use cases for it, so I'm not going to do it, but it is tempting. But here, error, wrong type, and this is an int type every time. That's the Boolean type. And we're going to have the same thing for characters, I suppose. Huh. Nope. Okay. But I suppose in the handling of constant expressions, there is going to be... Yeah, there we go. This is a Boolean type. I guess I could just do int path to int type, character path to character type, and boolean path to boolean type. And here I have a few cases where I'm testing that the type matches. Instead, I can match here that this is a Boolean type. That's the whole point of using patterns, is I can use them in a match context. There we go. Sorry, this is not very readable, zoomed as much. Also, I think I'm just gonna give up on the alignment here, since this is two different levels of Ks. This doesn't add a lot of readability to align vertically here. Okay. Resolve target type. And because this is resolved target type, okay. Int literal expression, there again. Do I simply have... Oh, it's called C, not I. Do I have the same mistake here? I do have the same mistake here. This is not... This is completely wrong, I think. Because this is a target. So here this is pure int. This is wrong. This is what this is supposed to be. When we're converting from an enum to an enum, we get the int value of the enum, we do the test of bounds, and then we just return the enum type. We do the exact same thing when we're targeting an enum, but if the source is not, we do this case of the expression to retrieve the int value with ord and from enum. When we're targeting a non-enum, we do this with chr and to enum, and we do the same thing. Okay, I think now this will be better. Okay, I guess there's a few more int literal that are missing their expression suffix to fix. More than a few, I guess. Resolved target type. Alright, what is this? What is this one? Where is it coming from? Oh, that is an expression after our case. It makes no sense. It's a relic of before. Go away. Just gonna look quickly at this code without all of the zoom. It does repeat itself a tiny bit, which bothers me, but I don't think it's to the point where I want to do something about it. Oh, so we have... Actually, I think I want to introduce patterns because here I would be able to pattern match on this is a Boolean expression X, and it would match everything perfectly. Okay, I'm going to introduce, now that I have started, I'm going to go back to the AST, add this thing here, go to typed expression, and add a few patterns. Pattern int expression, which is a typed expression, which is something that given an int gives a type expression, and the pattern int expression of x is equal to a typed expression of int type with an int literal expression of x. I'm going to do that for all three that I'm using. Now I can go back to here, and instead of saying case of this complicated thing, I can say case of int expression of x. The result is pure this is no Boolean expression of x, and the result is pure Boolean expression of not x. Type expression something something something. This is an int expression of x. Bool expression. I think I fully named them in the case of the pattern. Yes, I did. So this is a pure int expression of minus x. Can I use... I guess at the very least, even if I don't do... Here at the very least, I can use int expression to simplify the return value. Okay. Is there anywhere else? Yes, here as a result, I can replace all of this. This is a Boolean expression. This is an int expression. This is a character expression. A string expression. I don't have the means to express that yet. Okay, this does reduce the boilerplate quite significantly. Okay. Here I can do the same. Int expression, character expression, Boolean expression. There again, reducing a lot the boilerplate by using the template alias. Okay. And I think this is about it. No, I have a few here where I can replace this with pure int expression. And here I can remove the spacing here that I think is not required. It might be auto-inserted back by my formatter. We'll see. Yep, it is. And here, I don't know it wasn't here though. Interesting. It was. Okay. Okay. Ah, yes. Oh, that's a mistake on my part. I cannot declare those here because those require the built-in types, which themselves depend on the AST. So that creates a loop, a circular dependency, which means I am going to introduce those patterns not here alongside the AST, but as part of the analysis. I'm going to put it at the end. Which just means that I need to take this thing here, pragma here, and put it in this file. Okay, a few more errors. Oh. Resolve names takes the full... it takes the full path info. I guess for this function that has only the name, I could create a fake path info. Which is the name and no arguments. There we go. And here the path is unrequired. Oh, wait. I am giving them the actual path info resolved. So what I just did was wrong. This is the path info resolved. Name. This is all good. However, I think we really don't need the path here, so this is fine. What else did we get wrong? Space. Okay, so now we're getting errors in the cast. Yes, this case still has all four, which I have changed. Okay, so we have some... Okay. Oh, interesting. Interesting. So here I have a monomorphization problem, which is here I am introducing an alias for report cast error, which is equal to report fail. But this assumes that this assumes that there's one type associated with it, which can be inferred from where it is used. And this, if I look at the definition of report fatal, it returns a thing which is any a value because it will have short circuited, so it can be anything. But if I use it first in the context where this a is an int, and then I use it in another context, then the type that will be assumed for the report cast error will be with a is int, and then if I use it again in another one, it won't work. So I need to make it clear. And I need to make it clear here. That report cast error is for all a. Something like this. The binding for enum shadows the thing. Okay. Okay. Just some name shadowing, which is the kind of errors we like, because it means we are basically at the end. And now that should compile. Okay, it does. That's great. So now we could already try const z is gonna be a character, and it's gonna be x as int. Well, that's a type error. Actually, we can try this and see if we get a type error. Error wrong type. We get expected character actual type int, so perfect. And if I do this as character, I am looking for the definition of z, the constant, and z is a constant with the name z, which has a type which is a built-in type character with no arguments, and its expression is a type expression of type character with the value of whatever this character is, the character 8. So that works for casts that make sense. Type A is a valid type, it exists. Oh, actually, type A being an int, this should work because A is a type alias to int. It does. Okay. But if I introduce a struct foo of, excuse me, a field foo that happens to be an int, if I try here to instead do x as foo, then I should get a cast error. Error wrong cast from int to foo, perfect. And I guess the last thing to do is now to add enum support so that we can try to test with, so I'm going to try adding an enum color red green, blue. There we go. To do add enum names to local scope. How do I do that? I guess the simplest would be to add whenever I add a enum to the local scope, I add its values pointing to the same name. Which means resolving them will resolve a value of a type, but the identifier being different. I think that works. I think it works, although it is a bit ugly, but I think it works. Okay. I don't think it's that ugly. It might be a bit surprising, is the thing. Okay. So that means here I need to change this. So this is identifying all the top level names in a module that we're about to compile. Oh, I need to do it for both the dependencies and for the local one. So this is not as simple as I thought. Hmm. I don't want to have to change this code. I'm gonna start with the local one, which I think is gonna be easier. The imports are a bit of a nightmare. Well, I guess. No, this is gonna be a bit of a nightmare because I'm gonna need to handle the case where. Yeah. I'm actually tempted. I am a bit tired. I am tempted to stop here. We've solved the cast, which is progress. And I'm tempted to make it a short stream for once and not get bogged into something complicated. We've accomplished one thing, which is to implement cast in the case of a constant, and it seems to be working. Now, the next big thing is this to do here, which is to add the enums to local scope so that we can test that. Yeah, I think I'm just gonna stop here for the evening. We've accomplished one small task, and better to stop after one small task than to get bogged down in something complicated. This also gives me a tiny bit of time until next Tuesday to think about how I want to do this. I think I know, it just means I'm gonna have to rewrite this ugly function, and I was hoping I wouldn't have to do that. Oh well. Okay, well, as a result, I'm going to stop here. Thank you everyone for tuning in, and I will see you on Tuesday.